And then, all right. What? Yes, no. We are going to, we're on page 1 of the packet, the yellow packet. So notice what I have done here. I've colored in the bases. We're talking about what these prisms are. We actually have some prisms. No, that's silver. Okay, well. So do we remember what kind of prism that's called? That's on your paper? Rectangular prism. So the way it's a prism, it's a triangular prism. The way you identify what type of prism it is you figure out what's the weird shape on it. So they're all gonna have rectangles in it. This one has a triangle. They don't all necessarily have triangles. Rectangular cylinder. Okay. So here, what we've written down here are all of the letters that are in these formulas that you need. Yes. Are we able to see this? Or write in the pencil? Probably not very well. That's okay. And then we have to realize, what is the lateral area? It's everything but the bases. Go, go, go! Okay, it's good. So when you hear that, and when that stops, that means it's done. Okay. Yeah, so if you, I know you'll learn this in junior high, the nets. We don't have to learn that here, you already learned it. So when you flatten out one of these shapes, it would turn into something like you've got triangle here, rectangle here, rectangle here, rectangle here, and then triangle here. That's what it would end up being. I know you have learned that before. We're not going to deal with this time. But notice what we have. This is a big rectangle. I mean, it's ugly because I drew it. But this is a big rectangle, and then these two are the bases. So the perimeter of our base would be the length of this side. That's the perimeter of the base. Then the height, how far apart the bases are, so that finds the total area of everything except our two bases. So that's what we're doing here, just to give you a visual. If you look at that and you're like, what the heck is going on? Just plug the numbers into the formula. You'll be fine. Okay, we're going to move on. Next page. We're going to come back to this page once we get to cylinders, but go on to page 2. Alright, we're going to start with this one. This one similar to the one we just talked about. I'm going to color in the bases. I need another color. This just is not going to work. I can't color in the lines, but that's is going to be. Alright, chatties. Come on. We've got our bases right here, the top and the bottom. The two triangles are our bases. I tried to color them in. I'm not very good at coloring. So that's what you get. But we're going to start with our lateral area, and then we're going to find the total surface area. That formula comes from the page before. I'm not just making it up. Our capital P is the perimeter of our base, and then the height is how far apart the bases are. Y'all wrote that down, so I don't know if you just mindlessly wrote it down, but that's what it is. The perimeter of our base. So we've got an equilateral triangle as the perimeter, or as our base. Yeah, so 4 is one of the sides. We need all 3 of the sides. Cut that in half. It's just going to be 12. So if that would be the perimeter if we found the side length of both bases. We only need the perimeter of one base. Is all we need. So 4 is one of the sides. 4 plus 4 plus 4. That's all you're finding. Yeah. A lot of times people give me 24 for that because they're like, oh, okay, the perimeter of both the bases is 24. We don't want that. Just one. And then in our height, how far apart the bases are. There's red up here, red down there. They're 7.2 inches apart. All right? try not to overthink this. Typically, your height is going to be the one number you haven't used yet, for the most part. So our lateral area is 86.4. Alright, cool. Now, we found our lateral area. We found everything but the area of the bases. So, we probably need to find the area of the base. So I'm going to draw that over here. It's 4. And our capital B is the area of the base. We wrote that down. I don't know if we thought about it when we wrote that down. But our capital B is going to be base times height divided by 2. Anybody know why we're using that formula? It's triangle. Yeah, so that formula changes every time depending on what kind of shape it is. Okay, so are these at a 90-degree angle? The 4s? No. So we've got to do this cool thing. It's the thing that never goes away. You get to do this over and over again. You've got to find the base and the height, and the base and the height have to be at a right angle. So we know that the base is 4. We don't know what the height is. Wouldn't it be 2? It is 2 root 3. So it would be 2 if this was our n, but this is a 30, 60, 90 triangle. This is 2n. This is n. This is n root 3. How do we know what the angle is? Exactly, yeah. So since it's an equilateral triangle, you cut that 60 in half, you get a 30. So that's how you know it's a 30, 60, 90 triangle. If it wasn't equilateral, you couldn't do this, but this one is. So 2 root 3 is going to be our height, because we know that n is 2. And then we just plug 2n right there for the height. So our base times height divided by 2. Our base is going to be 4. Our height is 2 root 3. 2 root 3. We're going to divide that by 2. Okay? We did this all last unit. This should not be new to you. Hopefully. So 4 root 3 is going to be our capital B. That's what we just found. Cool. Now we can move on. So I'm going to freeze this real quick. If you're wondering where this formula is that I am about to write down, it's under surface area on page 1. So it says surface area, S equals 2B plus L. I'm going to write it backwards, actually. So S equals L plus 2B, it's the same thing. I just learned it that way, so that's how I want to write it. Lateral area plus 2 areas of the bases. So hopefully we can understand why we're doing all this. You've got your L, which is everything but the bases, and then you have 2 bases, you're adding it to that. That's all we're doing. So S equals L. This is where these numbers are coming from. If you're lost, 86.4 plus 2 times 4 root 3. Alright, this unit, we're going to do something a little bit different. Some of you are going to be super excited. Some of you are going to hate it. We are going to we're going to put this in the calculator and find it in decimal answer. Now in simplified radical form. The main reason we're doing this is because big ideas, so our homework is going to call for decimal answers. So I want to make sure you know how to do it. We'll do it in the homework, or in the notes the same way it calls for it in the homework. So 86.4 plus, I'm going to put this in parentheses, 2 times 4 root 3. Yeah, 100.26. It asks for it in hundredths in the homework, so that's how we're going to answer it in the notes. If you put 100.25 into the big ideas, you will get it wrong. So make sure you know how to round. It's 100.26. Okay. Got it? Not too crazy. Let's move on. Number 2, these are actually easier for the rectangular prisms. Here's the deal with these. Depending on which bases you choose, your lateral area is going to be different. On the homework, they will always choose the top and the bottom face of rectangular prisms as the bases. So, do you necessarily have to do this? No, but on the homework you do. So, Yeah, you can do that. Yeah, so if you want to split up the different faces, that's fine, but you will have to find the lateral area. So, yes. So our lateral area equals perimeter of the base times the height. The perimeter of the bases on Big Ideas is going to be the top rectangle and the bottom rectangle. Just warning you. So the perimeter of this one down here is 36. I can't count. Okay. Because it's 12 plus 6 plus 12 plus 6, which is 36. And then the height, how far apart are the bases? Typically it's going to be the number you haven't used yet. It's also how far apart the bases are. So they're 3 units apart. 108. That's our lateral area. We have found the area of everything but the bases now. Let's move on. Let's find the area of the base. This should be pretty easy. The area of our base is 12 times 6. It's just the two sides of that rectangle. Everybody see where that's coming from? I colored the bases in. You're finding the area of those bases. 12 times 6 is 72. So our total surface area is L plus 2 of our bases. You gotta add another base or something. So 180 would just be one base. So 108 plus 2 of the 72s. It's going to be 252 centimeters squared. So in my opinion, these are quite a bit easier than like the triangular prisms or the one we're about to do next, the hexagonal prism. Yeah, I'm going to show you that you don't really have to draw it, because nobody wants me to draw that up there. It's ugly. Okay, a lot of this is just following formulas, plugging in the numbers in the right spot. I think you can do that. It's kind of why we save this for the end, because it's easy, and I know it's May, and we're not really into doing school. Oh, 252 centimeters squared? Alright, we'll look back at it. Yes. If I got any snacks?
52.
I have a banana, but I'm probably going to eat it. Maybe you give me a little piece of my banana later, I guess. I don't know. Probably not.
That's just cool.
How's that cold? I don't have any other food. I'll share. Alright, regular hexagonal prism. So, on the homework, you won't necessarily have pictures drawn on every time. If you can't remember that a hexagon has 6 sides, Google is your friend. Don't just stare at it. Use your resources. What's really nice is this gives you everything you need to find the perimeter and the height. Gives you the height, and it gives you the side length of one of the bases. So that's 14. If we want to find our capital P, the perimeter of the base, we know that 14 times the number of sides will give that to us. Yes. So our capital P, yeah, 84. So our capital P is 84, and then our height, it gives us that in the problem. Prism has a height of 25 feet. Boom. Where is this located? I don't know, but it's pretty tall. TARDIS. Thanks. Is it? Are you just like a student aide all the time? Is that all you do?
Kind of. I have 2 class periods that I'm upstate today.
Wow. What a day. Later. So the lateral area is 2100. Yay, we found the lateral area. We found the area of everything except the 2 hexagons that are on the top and the bottom. So we must find that. Preston doesn't want to. Alright, good to know. Okay, it's a hexagon. So if you don't remember the central angle of a hexagon, it's 30. Hopefully we're getting to the point where we're remembering that a hexagon's a 30, 60, 90 triangle.
Are we?
If you're not, that's okay. You get lots more practice throughout this unit. Woo! So 7 is the length of the bottom side of that triangle. It's a 30, 60, 90 triangle, so this is 2n, in root 3. This one's actually kind of nice because you don't have to solve for n. It's already given to you. It's 7. Once you figure out that half of the side is 7, you know what your n is. So our apothem is going to be, woo! 7 root 3. That's our apothem. So now we have everything we need to find the area of our base. Do we remember what the area of, yeah? Apothem? Good. We already have the perimeter because we used it here. So 1/2 AP is going to be our capital B. 1/2 times 7 root 3 times 84. Cool. 1/2 times 7 root 3 times 84. 1/2 times, oh crud, 7 root 3 times 84. Okay, we get this number right here. Okay. 509.223.
Why did you say it so like?
I don't know. That's just how it came out. Alright, that's the area of one of our bases. We need 2 of these bases to add to our formula. So our surface area equals the lateral area plus 2 of the bases. So our lateral area we know is 2100. And then 2 of these bases, 509.223. Okay, here's the deal. I don't know as far as every problem. Some of the problems, I just don't want to tell you something that is wrong. So it is possible that this is right, but I don't want us to round it here and then get to the end and it's off by like a decimal spot. Decimal place. Yeah, so I would wait to round to the end. Because it will be off just slightly. It's only off by like 1/100th of a place, but I mean, I'll show you what happens. If you multiply this times 2, you get 1018.45. If you multiply this one by 2, you get 1018.44. So I would just suggest that if one doesn't work, try the other one on the homework. So, you can get that anyway? That's the area of your base. And then you multiply it by 2. I have not added the lateral area yet. Yeah. And then you also have to add the lateral area. So we should be getting that. 318, 3,118.45. If you round it earlier, it's going to be 0.44. Just put the one in that works. You get as many chances as you need to figure out this homework. So if one doesn't work, do the other one. Feet squared. Cylinders? Mm-hmm. We're doing like pyramids and cones next time. Prisms and cylinders.
Next time, as in like not today?
Yeah, those. So we're doing 2 shapes today, 2 shapes next time. So cylinders. These formulas are coming from this page. This page. Notice the difference here. This is still L equals the perimeter times the height. Just the perimeter of a circle is their circumference. So these are actually the exact same formulas as prisms, but they just look different. Alright? So I'm gonna use L equals 2 pi r h, but just know it's the same as the perimeter. Well, because the perimeter of a circle is the same as the circumference. Right? So those are actually the same thing. I'm just showing you it's the same as this formula up here. But since all of them are circles, we write it like that. Never mind. Y'all just like look really confused. We're going to use this formula. I'm just showing you what 2 pi r is. Good. It's good, right? Oh, those are all of them that are already done. Two shapes? 3 shapes? So cylinders are one shape, prisms are the other shape. We're doing cones and pyramids next time. So, I mean, it's pretty clear on the notes. There's 2 sets of formulas. That's what we're going to do today. So, okay. L equals 2 pi r h. So all you need is the radius and the height. We're given that. We're just plugging these numbers in. L equals 2 pi. The radius is 6. The height is 5. Again, the bases are the circles. Whoa, there we go. There's the bases. They're all colored in. So our lateral area is 60 pi. All right, now we need the area of our bases. Because our lateral area, remember, are the 2 red circles. No, we are still finding surface area. We're going to do 2 days surface area, 2 days volume. So the area of our base is going to be pi r squared. Remember, area of a circle. So pi times the radius squared. Right? So our capital B should be 36 pi. You did this in like 6th grade. Man, come on. Pi r squared.
What did I even learn this year?
I blocked out a lot.
Why are you under the desk? Oh my gosh.
I blocked out a lot of my childhood.
So finding the area base, just write it down. We're good. I'm not writing. Maybe y'all are writing too slow. I don't know. So surface area equals our lateral area. So we found that over here. 60 pi. And then 2 of our capital B's. The capital B's will always be the area of the base. For a cylinder, our capital B will always be pi r squared.
Why is it capital?
Because if you put a lowercase b, it's going to be like this b right there, which is like the base length of that. The capital B is the area of the base. A lowercase b would just be like the length of the base. That's why they're different. So 60 pi. We're going to do area of a sphere on the 5th day of this unit.
I don't want to.
I was like 72 pi plus 60 pi equals.
Whenever we put pi together, does it just stay like this pi? Like it's not anything?
What?
So like, because we're gonna have to like add those together, so this pi.
Oh, we're going to go ahead and put it in the calculator this time.
No, I know, but like we actually put pi.
Mm-hmm.
Oh.
All right, 132 pi is our surface area. If it asks for it in terms of pi, you'd be done. If it asks for it in decimal form, you have to put it in calculator.
It's 441. Wait, 414.6.
There we go. Is that good? So 132 times pi. Pi is by h on this. So I'm going to click on that. And I'm going to go back up to pi.
414.69.
Yeah, so on Big Ideas, it does ask for it in to the nearest hundred, so decimal form. If it asks for it in terms of pi, that's what we'd be looking for. So here's what we're going to do. We're going to actually cross off 5 and 6, and instead of 5 and 6, we're going to do these on this other paper. Haha. And then I'm going to pass the stapler around. We're stapling this extra sheet of paper to the back of the back of our packet. Let's do these 2 problems, then you can fill your water bottle up.
Okay.
Alright, what 2 shapes do we have on this first one?
Rectangle, prism,
Cylinder.
semicircle. Semi-cylinder. That's what it's called.
Is it?
Technically speaking.
Okay. Yeah.
It's actually a shed.
So 1/2 of a cylinder, right?
Yeah.
So for these compound shapes, I would highly suggest that you write down what you're doing because it gets confusing. So 1/2 of a cylinder is what the top part is. So we're going to find the entire surface area of the cylinder, and then we'll cut it in half. Great. Then what do we have going on down there? Y'all said prism. Yep. So we have a prism. Is there anything that is covered up from that prism? Yeah, so the top, and remember what I talked about with big ideas, they always use the top and the bottom as the bases. So it is missing a base, is what that means. Because that half of that cylinder covers up one of the bases. So what are the things we need? Well, we need half of the cylinder, we need the lateral area of the prism, and we need 1 base of the prism. Does everybody see why that is the case? So the cylinder's cut in half, so that's why that's half of it. We need the entire lateral area of the cylinder, which is everything around it. And then we only need 1 of the bases, because 1 of the bases is covered up by the cylinder. So, yes, these shapes right here take a little thinking before you're just plugging in numbers. You have to figure out what you're trying to find. We only want the outside surface area. Alright? So let's start off by finding, for our cylinder, the lateral area, which is 2 pi r h. So let's all write that down. Do you have to memorize these formulas? No. Right. Okay, so here's the deal. Yes, you could do that. You can find the lateral area of that, and then you can just find 1 base. That is the way you can do it. The way I'm going to do it is just find the whole thing and cut that whole thing in half. But yes, the reason I hesitate to just cut that in half is because sometimes people cut that in half and then forget to cut the bases in half or something. You have to do both. And this way you only have to cut it in half once. But yeah, that's another way you can do it. That's perfectly fine. I'm A-okay with that. 2 pi times the radius times the height. Okay, the radius is not given here, but there's a way to figure it out. It's 3 because these little tick marks. The diameter is 6, so the radius is 3. And then our height. How far apart are the circles?
6. Wait, no. 10.
10.
Yeah, so that is something that a lot of people miss. A lot of people want to put 6 for that height. But we are focusing on the cylinder right now. The bases, which are the 2 circles, they're 10 units apart. So that's why 10 goes there. So L is 60 pi. Alright, now we want to find our capital B, which is pi r squared. So our capital B is going to be 36 pi. No, sorry, 36 pi. I'm going crazy. It's going to be 9 pi. because our radius is 3. Okay, there's 2 ways to approach this. Go ahead and find the total surface area and cut it in half, or you can cut this lateral area in half and only use one base. You can also do that. Okay, which part? This? This is an arrow, but I'm terrible with arrows. The radius is 3. Whoa, that's crazy. So our surface area formula is L plus 2B. If we cut that in half, then our surface area is going to be half of our L and then 1 base. Okay? This tends to confuse people when we write it out like that. So, yeah, but you also have to cut the L in half. So, here's what I'm going to do. I'm just going to go ahead and find the total surface area and cut that whole thing in half. If you get what's going on, then you don't have to do all this. Okay? So our S is going to equal our L, which is 60, plus 2 of our bases, which is 36 pi. And we end up getting... Mother of pearl, where the heck is 36 pi coming from? Why? Like, I really, really want this to be 36 pi. But it's not. Like, I wrote it earlier, and now I'm writing it again. 9 pi is the B. Okay, so 78 pi. That's our total surface area. But we only want half of that total surface area. So just cut that in half, divide it by 2. So 1/2 of our S is going to be 39 pi. Cool, we found this piece. Okay? This takes the longest. These other 2 parts are super easy. Uh-oh. You can just rewrite it on the top. So the lateral area of the prism, our L is going to equal capital P times H. We must first remember what is the base, the perimeter of the base. 6 plus 10 plus 6 plus 10. Yep. And then, this is what a lot of people get wrong, because we used 10 for H here. 10 is not our H on this one. It's how far apart are these red things. They are 6 units apart. They're not 10 units apart. 10 was the height of our cylinder. I'm just going to beat that into the ground. $32 is 6 plus 10 plus 6 plus 10. Yep, 192. Thank you. All right, now we need to find the area of one base.
39 pi.
Good. So B equals 6 times 10. B equals 60. Yay! Now we can add all of these things together. 39 pi plus 192 plus 60. It is highly beneficial for you to write all of these things down in advance so you get to the end and you know what's going on. Okay? Yeah, I'm going to go ahead and put all of this in the calculator because remember, we want the answers in terms of like decimal answers. I don't know why I keep saying that. Yeah. So when we put all of this in the calculator, we get 374.52 meters squared. Yes. Go ahead and put 39 pi in the calculator. I know we didn't do that last unit. We are doing that this unit. And then we have one problem left.
Yay!
Yeah, like, see, every time I wrote out, like, this is the formula, and this is what you plug in. So it's actually a lot longer than what you will do on the homework. It just looks like it's probably twice as long as what you would actually write. So I just did that so people aren't confused. 12.2, the last question. This we're gonna have to use our brains a little bit. Oh man! Yeah, this one is easy, but you have to, let's think about it first, real quick. What two shapes do we have? Say them out loud. Cylinder and a prism. Okay, so the total surface area for both of these are L plus 2B. L plus 2B. So we've got to figure out what of those two things are not showing. Because if we just take both of the total surface areas and add them together, we would not be correct. Because their stuff is being covered up. What on this cylinder is being covered up?
A portion of the bottom.
How much of the bottom?
That.
The whole base, right?
Yeah.
So we can take away one base of the cylinder. Okay? What is being covered up on the prism? Focus on the prism only. Portion of the top. Yes, that is true. What portion of that top? The circle. So how many circles are being covered up?
One.
One on the prism, and how many on the cylinder?
One.
What's 1 plus 1?
Two.
2. Okay, so let's say that again.
Oh no.
One circle is being covered up on the cylinder.
Okay.
What is being covered up on the prism?
A circle.
The exact same size circle.
Oh.
Okay? So how many circles is that?
Two circles.
1 plus 1, right? 2. So 2 circles on the cylinder are being covered up. But then you'll say, but Coach Brown, I can see a circle. Okay, so here's the deal with that. That circle is being covered up on the prism. So if we find the total surface area of the prism, you have to take a circle away and then you'd add that. So why would you take a circle away just to add it again? That would be silly. So just take away both of them. Alright?
Wait, what was it originally 2B?
So it was 2B, but 2 circles are covered up, right?
Oh, so I get it. It was just if we're supposed to add another circle, then why are we getting at least one base?
So here's the deal. One circle is covered up on the cylinder, and that exact same circle is covered up on the base.
So we have to take a circle out and then add it back.
So what would that end up being? Taking a circle away and adding it back.
0.
Just nothing would happen, right?
Oh,
Okay?
yeah.
So we're just not going to do that. What we're going to do is just take the circle from the cylinder away, take the circle from the prism away, and that just leaves the lateral area of the cylinder. This, I mean, it is hard to think about and to understand, but once you see it, it kind of makes sense. This exact type of shape, you will see it again, possibly on the quiz, possibly 2 class periods from now. It will be the same type of thing. You've got to be able to look at it and say, okay, all I need is the lateral area of the cylinder and the surface area of the prism. That quiz is not multiple choice, so you will actually have to know how to do it. Okay?
Is it a partner quiz?
No, it's not a partner quiz, but thanks for asking. So lateral area of the cylinder is 2 pi r h. So 2 times pi, and then our radius is given to us. It's 4. Our height is also given to us. How far apart are those circles? They're 8 units apart. Okay, so I went really fast there, so I'm going to take my arm away. I'm going to make sure you have all that down. Now, all of our thinking is done. We're just plugging numbers into formulas now. Surface area of the prism. So our lateral area. What? Didn't give you enough time? I'm just coloring up here. Just trying to remember the days of kindergarten. Good memories. Here we go. You hated kindergarten. Who hates kindergarten?
No, my teacher always carried around a notebook, and my name was always in it.
Oh, sounds about right.
Oh.
Haha. Just kidding. So the perimeter of our base, here's our base. I colored it red. So we take 14 plus 8 plus 14 plus 8, and we get 44. Okay, I put it in the calculator if you don't believe me. Yes.
14 plus 8, 14 plus 8?
Yeah. Okay. Oh, yeah, we're good. And then how far apart are those bases? Yay! They're 12 units apart. And so that gets this really big number, 528. Oh. Alright, and then our area of a base is pretty easy. It's just 14 times 8 because, well, it's a rectangle. And then if you put that in the calculator or you just use your brain, it's 112. Almost. Alright, now we need to add our L plus 2B. L plus 2B. So here's our L. Here's our B. We're just plugging those numbers in. I'll move this up. 528 plus 2 times 112. Yes! 752. So 64 pi plus 752. That would be our answer in terms of pi. But if they want it in the nearest hundredth, it would be yep. By far the longest notes video I've ever